Okay, so this is day 4. The assignment's on it, but this is the warm up, and we're going to do a little bit of notes on here. So, really, this is just an extra day to get really good at what we were doing yesterday. And there is kind of one variation of problem that showed up on last night's homework that you might have tried and checked your answers against solutions and gotten horribly wrong. I'm going to show you guys how to do those today. Those are called rational inequalities. We'll do one on the warm up. We'll look at the ones from the homework. You should try those, and then we'll go over them. And then there's another example on this. And then tonight's homework has more of those, plus some of the others. So for the warm-up, you should pause the video, try all these problems, and get your answers for 1 through 7. You could try 7. You could kind of skip it if you're not sure. And then unpause it and go over it with me and make sure you got the right answers. You can fast forward through the ones that you know you got right after you see my answers or whatever. And in fact, right now, what I'm going to do first, okay, so pause it. And when you come back, I'm going to just show you the answers first thing. You can check them, okay? So you guys pause it. Now you've tried the warm up. Here are the answers. Check your answers. And they need to look just like this. They need to be interval notation, and mark anything, mark them wrong, write the right answer next to it, and see if you figure out what you did. If it's a simple mistake, then that's by far the most useful thing you can do. Next, I'm going to actually go over them in detail, but see if you can figure it out first. And if you can, no problem, then you've figured it out, okay? Otherwise, I'm going to show you how now. So, these first ones, I personally, they're not very hard. They're not really calculus, but I like to draw little number lines. I do this. I don't think it takes very long. You're going to have a few of these on your first test. So solid dot for brackets and the arrow to negative infinity. And the next one is 2 to 6, and that's open at 2, solid at 6, shade in between. Now, this is union, which is like marriage, which is like or, meaning everything is going to be combined together in the final solution. So all these points work, all these points work, all the way up. So it's negative infinity to 6, bracket, parenthesis. That's your answer. It doesn't matter that this is an open dot because it belongs to this guy. And in fact, all these don't belong, but they belong at least to that. And these belong to at least one. The ones they have in common is okay also. That's your answer. The next one is another union, so that's or. So you got to remember what that means. And so it's going to be open dot at -2, solid dot at 3, shade in between. I just try and line these up relatively correct. So a 2 should be between -2 and 3. 5 should be to the right. Open solid dots. We're looking for either one to be true. Everything that belongs to one or the other is going to be in your final answer. So that's going to be -2 to 5 parentheses. Okay, next one is and, which is the same as intersection, which is like this upside down looking symbol. And so I'm going to just draw these lines real quick. -3 to 5, solid dot at 5. And open dot at 0 and open dot at 5. And we need them to both be true. So that's going to be 0 to 5, not including 0 because it doesn't belong to both, not including 5 because it doesn't belong to both. There's an open dot on this one at 5. It has to be true for both for it to be an and intersection. Okay, so that's interval notation and simplifying, multiple intervals. Now these are polynomial inequalities. What you should be doing is moving everything one side compared to 0. Hopefully you can factor it, otherwise you use quadratic formula or some other method. -3 plus 2 gives you -3x plus 2x is a -1x in the middle and -6 there. So x equals 3, x equals -2. Then we do a number line. These are going to be open dots because it's not or equals 2. We're going to test a single value. If you're testing every region, you're doing it wrong. It's gonna be tons of work this year. And we need to be fast at these, really fast. I'm going to test far right. Test x equals 4. Tell me what you're testing. I need to see that in your work to give you credit in your test next week. Positive is false, true, false. Now, it's going to just flip back and forth between true and false unless there's a root 0 that has an even power on it, which it wasn't. So the final answer is negative 2 to 3, parentheses. This one is nicely factored for you, all on one side to 0. So a lot of that hard upfront algebra work has been done for you. But this guy has an even power. This guy has an even power. This guy has an odd power. That's fine. Every extra time a root gets repeated, it's going to act like it's going to go through or not go through, change direction at the x-axis. Make a number line, left to right, smallest, biggest. These are all solid dots, which you should be doing to make sure you get the right. Make sure you include them in your final answer. Test x equals 3. Positive, positive, positive is false. Stays false. Flips now. True. Stays true. So whatever it is on one side. Oh, hold on a second. I screwed that up. This is a star and this is a star. So I messed up. I was looking at the stars from up here. So it started false. It is going to flip to true, but then it's going to stay true. And it's going to stay true because these guys had the even powers on it. 1 and 0 did. Okay? So your final answer is actually just negative infinity to 2 bracket. Parenthesis on infinity always. Because you don't break it up here because those are solid dots. If they were open dots, you have to break it up. But that's your answer. So number 6, we're going to move everything to one side, equal to 0. So this one I'm making do a little more work. Factoring, let's try grouping. If you do grouping, you say, well, I could take x squared out of both of those. That'd be x plus 1. I could take a minus 1 out of both of those. That'd be x plus 1. Oh, grouping works. Now, maybe I'll show you synthetic division in a second because that's what you're probably usually going to have to do. Grouping usually doesn't work out, but it's nice when it does. So, I mean, I would just try it because if it works, it's worth it. Now, you want to keep factoring that difference of squares. You want to factor down, and then anytime you have some of the same type, regroup them so you can remember that. So x equals negative 1, x equals 1, x equals negative 1. I'm going to put a little star next to it because it bounces off the graph, and I got to remember that. So then I'm carrying this inequality symbol with me the whole time in the zeros. So these are going to be solid dots at negative 1 and 1. I'm going to test a single value anywhere, but I like far right. Positive, 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 which is true. False. Oh, the negative 1 is the star one, so I got to remember to do that. True, false, false. So here's your answer. Now this is a mistake a lot of people are going to make. They're going to say 1 to infinity bracket parentheses, and they're going to be like, that's my answer. But hey, this is a solid dot. That is a lone answer. So this is the way we write it. Don't forget that lone answer. I guarantee I'm going to do that on your test next week. Guarantee it. Okay? I'm going to give you one that's going to be easy to miss. Now, if it was an open dot, you don't write it. Open dots aren't solutions. Now, for the new kind of problem, okay? The new kind of problem is this. We call this we call all these guys polynomial inequalities. Polynomial inequalities. And this is all algebra stuff, by the way, guys, right? I mean, you could learn this in Algebra 1. This is called a rational inequality because this is called a rational function. And you guys should have studied these before in probably Algebra 2, even Algebra 1. Now, here's the deal. We're going to do a lot of the same things. The mistake that some people are going to make, and I'll show you the way that some people do it. They say, oh, well, let's cross multiply. Because a lot of times we like to do that, make things simpler. And then they're like, all right, then we subtract x from both sides. And then we divide both sides by 3. And then we could flip this all around. And then my answer is going to be negative 1 to positive infinity. Fortunately, that's wrong. Okay? So so this is a lesson we got to learn right now. With even equations, rational equations, cross multiplying can get you into trouble. It can for sure make you lose answers. So my approach to these, even the equations, is not to cross multiply. Okay, if there's any variables in any of the denominators, don't cross multiply it. Okay, if there's numbers, who cares? But this is the way you want to do it. You want to move everything to one side. Oh, you mean just like what we've been doing on all the other ones? Yes, just like the same thing. Now, here's one of the big differences. I want to get this all into one big fraction, okay? So I got to give these guys least common denominators. So this one's pretty easy. Multiply top and bottom by x. So this is going to be x minus 3 minus 4x all over x. Let's make it one big fraction, and then let's simplify it. Simplify the top, group like terms, okay? Now, that's what you want to do. Move it all one side, equal, compare to 0. Give them least common denominators, put them in a big fraction, simplify it, and now let's factor the top and let's factor the bottom if it needs to be factored, okay? Now right here, this guy, x equals -1, well, that's a root. That's an x-intercept on your graph. But this guy, x equals 0, causes division by 0, which is bad. That doesn't make this go to 0, it actually makes it go to infinity. But on a graph, that's important because that's a vertical asymptote, okay? And most graphs, well, if you were to just graph the most basic y equals 1 over x graph, this is just a little bonus, the graph would look like this. And it would have this vertical asymptote right here, vertical asymptote at x equals 0, where it causes division by 0. And on one side of the graph, it'd be up here. On the other side, it'd be down here, which would cause your inequality to change from true to false, because it's going to change it to positive or negative, which is going to make it flip its true falseness, right? So on vertical asymptotes, we have to put those on a number line because they're going to change unless they have an even power. Then both sides would be up and it wouldn't change. So we're kind of doing the same thing. We're going to put this guy, we're going to do a line check. We're going to put the -1 on there, and we're going to put the 0 on there. And if either of them have even powers, make sure you make note of it. Now, we're going to test a value. X equals 1, positive, but it's all get multiplied by negative, which is true, false, true. So we make it about as easy as the other ones, and then you write your answer. Now, one thing you got to watch out for, so this is your final answer. Okay, that's your final answer. And that's the way we do it. Don't cross multiply. Now, one thing you got to watch out for is if there was an if there was an or equals to here, bar, then you'd be like, oh, let's make all the dots solid. You would make the dots from the top solid because those are actual x-intercepts. But vertical asymptotes, the graph doesn't exist there. So you can't say that there's an answer from a graph where the graph doesn't even exist. So anything from the bottom will always be an open dot no matter what's going on over here. Okay? Bottom's always an open dot. Top is open if this is not or equals to, solid if it is. Bottom's always open. So let's try another example. Let's try this one. And, see if you can, this one's a little tougher than the last one. See if you can pause the video and stay ahead of me. See if you can pull it off. You need to convince yourself you can do this on your own. Just watching me do a bunch of them is not going to help you get really good at it. Okay? Now, if you're not sure what to do, then unpause it and see what you should do next. I'm going to move everything to one side. No cross multiplying. Okay? I'm going to give them least common denominators because I want to combine it into a single big fraction. Now, the least common denominators need to have an x minus 1 and an x plus 3. Whatever you do at the bottom, you got to do the top. Now, be careful. This negative has to get distributed here, right? So then I'm going to get, now the top, I'm going to go ahead and distribute these guys. X squared minus x minus 3 all over. Now, the bottom, don't distribute the bottoms. The bottoms are the same, and you're going to want to factor them anyways. So leave the bottom factor. Now, the tops, they got to be all combined back together before you refactor it, because you got to combine all those terms together. So, and then we're going to simplify the top, group like terms, put it in standard form. Okay, leave the bottom factored. Otherwise, you're just going to have to redo that work later. Now, let's factor the top, x minus 3, x plus 1. x minus 1, x plus 3. Okay, now if there are any roots that are the same on the top or bottom, then they kind of get counted as a total of like the even number. If you have an even number, even if it's an even number combining top and bottom ones, then that means it's going to bounce. But these are all unique. So x equals 1 and negative 3 are vertical asymptotes, which need to go on a line check. And x equals 3 and negative 1, those are x-intercepts. Those are roots. And everything's an even power. So all of this is going to go on our line check, left to right, smallest and biggest. So negative 3, open dot. Negative 1 is a solid dot because it comes from the top and we have the or equals to. Now the bottom are always open. Then positive 1 is an open dot because it comes from the denominator, vertical asymptote. Can't be an answer. And then positive 3 is a solid dot. They got to be in order left to right. Okay? Now, graphing this, by the way, trying to do this with the graph sketches would be insane, okay? So we're going to test x equals 4, okay? That's what I'm going to do. Far right, positive, 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 positive. It's all positive, which is true, false, true, false, true. Darken in the trues. Those are your answers. Final answer is negative infinity, negative 3. Parentheses, union, bracket negative 1 to 1, parentheses, union, bracket 3 to positive infinity, always parentheses on infinity. You cannot actually hold infinity. So that's how you do these problems. Now I'm going to go over the 2 homework problems, okay, from yesterday that were on this. You should pause it and try those yourselves, okay? Now the back of this is tonight's homework. So tonight's homework, you're getting some more practice on the problems that we've been doing, okay? It's just another day, okay? Use whatever the best technique is. If it's linear, don't do line checks. Just get x by itself, right? All right, so I'm going to go over those 2 problems from last night's homework. And that's 11 and 12 from assignment 3, okay? Now, try these right now. If you haven't tried them, try them. I just showed you guys how to do this. Try it. This is a good opportunity to right now quickly evaluate if you're ready to do the homework tonight on your own. So try these first. Now, both of these are really ready to go. They're all on one side, equal to 0. They're all factored. They're all on one big fraction. So this is as easy as it gets. Now, this guy has an even and even, so we got to keep track of those. So we're going to do a line check. Solid dots from the top one. So x equals 1 should be the first one, solid dot. X equals 2 should be the second one, solid dot. Put a little star next to that guy. That bounces off the graph. And then 3 has to be an open dot because it comes from the bottom because vertical asymptote causes undefined, which cannot happen. And it has a star too, but we got to put that on line check. Test a value. Tell me what you're going to test. I test far right. 4. Positive, positive, positive. That's why I like test far right. Everything's positive usually, which is true. Stays true, then starts flipping like normal. So on the ones that have the even powers, it stays the same. Okay. Now your answer is going to be 1, bracket 1 to 3, parenthesis, union 3 to positive infinity. So we have to break it up at 3 because 3 is an open dot. If 3 were a solid dot, then we would just make one big answer. Okay, just like 2. We didn't break it up at 2. Don't need to. This one right here, x equals 0, x equals 2, x equals negative 3, x equals negative 1, x equals 4. There's the only even exponent. Odd exponents are fine. So you're going to make a line, left to right. The ones on top are solid dots. Negative 3, negative 1's an open dot, 0 is a solid dot, 2 is a solid dot, and 4 is an open dot. So make sure they're on there. You got 5 dots. Now, which one? That's the one we got to watch out for, that negative 1, right? Test x equals 5. Positive, 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 which is false. It's not less than 0. True, false, true, true. Stays the same, then goes back to alternating false. Okay, so the answer is -3 to -1, bracket parenthesis, union -1 to 0. You got to break it up at -1. Union 2 to 4. Okay, this is the way fastest way to do these problems. Okay, so that's those two problems I didn't do on the homework from before. But now you're going to try assignment 4 on your own. I'll put the answers online so you can at least check and see if you're getting the right answers, and maybe you can figure out what you did wrong after just looking at the answers. It might be a simple mistake like a bracket or parenthesis that you missed. All right.